recent years, places like California, Australia, and Amazon have been subject to devastating wildfires. These wildfires start without notice and become too powerful by the time they are detected. They destroy tens of thousands of acres of land and cause billions of dollars in damage. Currently, there is no simple method to detect them before it is too late. The Drones for Humanity team seeks to greatly reduce the damage caused by these wildfires by spotting them early on. We aim to accomplish this by creating a fixed-wing, autonomous UAV to scan an environment with thermal imaging to identify small wildfires and report these locations to help stop them before they can't be contained.
I'm Matthew Becker, and as the systems engineer for the Drones for Humanity, I'd like to introduce you to the Pink Panther. The Pink Panther is our fixed-wing, fully autonomous UAV with a 2-meter wingspan and a 1.5-meter fuselage length. Our horizontal stabilizers are 1 meter in length, and our vertical stabilizer is about 0.5 meter in length. Our aircraft has a weight of 11.8 kilograms, which saves enough space for a 5-kilogram droppable payload. Our aircraft also comes with two 710 kV motors and 12-inch by 8-degree props. These props and motors are capable of producing enough thrust to carry the aircraft forward at about 25 meters per second during cruise. We also have a 16,000 milliamp hour battery that powers all of our systems and can give us an approximate flight time of about 45 minutes. We took some of our inspirations from the Airspeed Horsa, which was a World War II heavy glider capable of carrying troops as well as vehicles. From this, we took their airfoil, which was the NACA 4418. It has a high enough camber for heavy lift at lower speeds. We also took some of our sizing and fabrication techniques from the model surveying drone, the Believer. As for our avionics, we run all of our flight systems off of a Pixhawk flight controller, which can be used for autonomous or manual flight. We also have our configuration set to, in the case of an emergency, we can switch between manual and autonomous flight at any time. We run our imaging software off of the GoPro Hero 3 and a Raspberry Pi. Through the use of a neural network, the aircraft is able to detect fires from below based on pixel coloration.
To manufacture the Pink Panther, 6-inch diameter PVC tubing was cut to length for the fuselage size. Cuts were then made into the fuselage for the payload bay and access hatch doors, and holes were drilled and tapped to connect the landing gear and wing spars. To create the nose cone and tail of the aircraft, low-density foam was used to cut with the hot wire CNC. Similar process was used with the wings and stabilizers. The hot wire CNC is a machine that uses a wire with an electric current running through it to heat up and cut through soft materials such as foam. To machine the spars and structural supports of the stabilizers, a drill press and mill were used to create holes. Screws were used to connect the lifting surfaces to the fuselage and keep them in place. For internal parts, a metal plate was screwed into and manufactured to hold the propulsion subsystem battery, flight controller, first-person view camera, servo controller, and thermal imaging computer. Servos for controlling lifting surfaces were placed into the foam pieces by cutting boxes out of foam and taping the servos into the boxes. Motor and servo housings were 3D printed with the Ender 3 printer and using ABS plastic.